I'm Anil Kumar, and in this video, we'll try to understand when and how to apply L'Hopital's rule. The basic thing is that L'Hopital's rule can be applied when we have indeterminate form. The question here is, can you find the following limits using L'Hopital's rule? We have two examples which are very similar. The first one is limit when x approaches infinity for ln x over x. The other one is limit when x approaches 0 from the right side for the same function ln x over x. You can pause the video, answer the question, and look into my suggestions. Now as we move on, you'll find many examples where we'll take up logarithmic functions, exponential and trigonometric functions. So it is very important to review these functions. Okay, let's begin with this, ln x over x. So what I will do here is kind of make a rough sketch for this function. So ln x is a function which is kind of like this. I'm just sketching roughly, right? So no scale is here. And as you know, x goes diagonally like this, kind of, okay. Now, so this is the x-axis, that's the y-axis. Here we have the origin, and this point is at 1. So ln 1 is 0. What we see here is that, let's look into the first function, which is we need to find the limit as x approaches infinity. So you can see as x approaches infinity, the numerator approaches infinity, and the denominator also approaches infinity. So what we can do here is think like this. As x approaches infinity, ln x approaches infinity, right? So this is approaching infinity. As x approaches infinity, x also approaches infinity. So what we have here is kind of infinity over infinity, right? So that is indeterminate. We really don't know which number is bigger, equal, smaller, so what is going to be their quotient, correct? So that is where the L'Hopital's rule come into action. Now, how do we apply it? Now, what we know is that if we're trying to find quotient of the functions, then their limit is same as quotient of their derivative. So that's the strategy. So we can write derivative d dx of ln x divided by d dx of x. Now the limit x approaches infinity for derivative of ln x is 1 over x, and that of x is 1. So this we get 1 over x over 1, which is, now we can again write limit, simplify this, x approaches infinity for 1 over x. Now if I substitute infinity for 1 over x as infinity, so I get this as equals to 1 over infinity or 0, right? And therefore we can conclude that this limit is indeed equal to 0, right? So that is how, by application of L'Hopital's rule, we can find the derivative of this indeterminate form, right? Now let's look into the second one. Now here we have ln x over x, but the limit is for x approaching 0 from the right side. That means you're approaching from this side, right? From the right side. So what happens to ln x? ln x is approaching negative infinity, right? So we have in the numerator negative infinity. How about denominator? It is approaching 0, right? So we have negative infinity over 0. Now mind it, this is not indeterminate form, right? And therefore we cannot apply this rule to find the derivative, right? Now the question is, what is the limit of this function, right? So that is for you to answer. Limit of this function when x approaches 0 from the positive side. Well, the answer is actually clear if you see from the figure. ln x is approaching negative infinity, right? and this is approaching 0, a very, very small number approaching 0. So when you divide by this, I mean, you cannot divide by 0, but a very small number, the result is going to be equal to negative infinity, right? So the answer here is negative infinity, right? However, you cannot apply this. If you find derivative of both, you will get answer as 0, right? Which is, okay, well, you might get positive infinity, because you'll do this, all this math, and then if you substitute 0 here, you get 1 over 0, which will be positive infinity. In fact, you see that the answer is truly negative infinity, right? So remember, this rule can only be applied for indeterminate form, right? Not otherwise. So that is the take from this particular video. I hope that helps. Thank you and all the best.